drawing sheets. What would be the size of the drawing sheet? What would be the paper of the drawing sheet? Well, the drawing sheets are made up of the cardboard paper. Generally, mechanical engineering students will use the white drawing sheets. The size of the drawing sheet would be A2. Now, we'll see that in our regular life, in the printing paper, we have seen the paper and we are very much aware to this A4 size paper. This methodology is very much simple. The digit beside to the A, which is a denotation to the ANSI unit. We have discussed in the previous part that ANSI is a standard for the America. Now, most of the paper size we are choosing according to the American ANSI standard. Now, A stands for ANSI and 4. We are using A4 paper for our using day-to-day printing purpose. If we combine two A4 size paper, it becomes A3 size paper. If we combine two A3 size paper, it becomes A2 size paper, which would be ideal drawing sheet for our use purpose. If we combine these two A2 size drawing sheets, then becomes A1, and if we combine two A1 size sheet, then it becomes A0 size sheet. Now let's see what are the exact MMs of these drawing sheets. The trim paper of a size is called as A0 to A4. As I have told you that if the basic size is A4, if we combine two A4 size paper, it becomes A3 size paper. Exactly two A4 size paper means that A3 size paper. Two A3 size paper consist of a A2 size drawing sheet, which is our essential drawing sheet. When you are drawing any sort of drawing sheets, you will be having 8 to 9 drawing sheets according to the syllabus, and when you are going to purchase the drawing sheet, ask the stationery guy that I need a white A2 size drawing sheet. White A2 size drawing sheet. In the market, some cream drawing sheets are also available, but do not purchase those cream drawing sheet. Ask for white drawing sheets only. If we combine these two A2 size drawing sheet, it becomes A1, and if we combine these two A1 size sheet, it becomes A0 size. Here are the standard sheet size. Again, as you can see over here, JIS, which means that Japanese standard. JIS. A4 consists of 210 to 297. A3 is 297 into 420. The last figure would be first figure for the next portion. A2 420 into 594. A1 594 into 841. A0 841 into 1189 mm. All dimensions are in mm. So these kind of sheets we can use. This is our outline of a A3 size drawing sheet. I have given the outline of the A3 size drawing sheet. Its measurement is 297 into 420 mm. We need to keep some sort of margins for the binding purpose as well as the folding marks purpose. So over here the margins have been set. This is called as border line. Generally the margin of 10 mm leave on each side. On the lower right corner we will have our title block. The title block consisting of various things: company name, drawing component name, who have drawn this drawing, when the drawing was drawn, and etc. This d distance implements the margin of the drawing sheet. Now we'll see some sort of videos related to this Cognifront software which we are using to widen our knowledge.
Graphics and drawing. In this presentation, we will understand basic concepts, tools, and techniques used in engineering drawing. Engineering drawing is a technique of creating graphical representation that contains all necessary information such as dimensions, specifications, and notes, using which an abstract concept can be transformed into a real-world entity. Applications of engineering drawing are varied. For example, shipping industry, manufacturing, construction, and many more. Alright, so before we actually start drawing something, let's warm up with some important concepts. So first, let's take theory of projections. The word projection means to throw forward. It is a process of plotting an object or entity on imaginary planes. Projection has two types. First is parallel projection and second is perspective projection. Each of these in turn has further subtypes. We will focus on orthographic projections where the projectors are parallel to each other and they intersect the projection plane at right angles. We will study orthographic projection in detail later. So let's take a look at important tools used in engineering drawing. Drawing paper, drawing board, drafter, T-square, compass, divider, French curves, protractor, set squares, scales, pencils, erasers. Before you start drawing, always make sure that the size of drawing paper is less than the size of the drawing board. Also make sure that paper is fixed properly with drawing pins and it is smooth without any wrinkles or folding marks. The drawing board is a plain and smooth surface used for drawing purpose. The ebonite edge of the drawing board facilitates smooth movement of T-square. The T-square, as the name suggests, is a T-shaped drawing tool. Its straight edge slides along the width of the drawing board with the help of a stalk. It is useful in drawing straight lines and also serves as supporting edge for set squares while drawing inclined lines. As you already know, the compass is used for drawing circles and arcs. The divider is a little different, with both legs made of steel and is used for transferring distances. Another interesting tool is French curves. They are used to draw irregular curves such as ellipses, parabolas, hyperbolas, and the like. The drafter is a very useful tool for drawing parallel lines at any given inclination. It has scale as well as protractor inbuilt. Looks like a robot, isn't it? Protractor is used to measure and lay out angles. Another tool is set squares, also known as triangles. They come in flavors of 30, 60, 90 degrees and 45, 45, 90 degrees. Alright, so we are all set to now begin understanding basic concepts of drawing, which we will cover in the next presentation. So let's continue the discussion of geometrical constructions for line tangents and arc tangents. But first, what is a tangent? A line tangent to a circle is a line that is perpendicular to the radius and touches the circle only at one single point. The intersection of these two lines is called as tangent point. Now, where do we need tangents? In machine drawings, very often we will have to gradually merge a single line into an arc with a smooth curve, and also we have to connect two arcs with another arc, making the transition by a smooth curve. And this is where we need tangents. We'll proceed with explaining the construction of an arc which is tangent to given arc with radii r1 and r2 and with the centers as x and y. The required radius of a tangent arc is r3. Take x as center and radius equal to r1 plus r3. Draw an arc a dash b dash. Similarly, take y as a center, draw an arc c dash d dash with radius equal to r2 plus r3. The arcs a dash b dash and c dash d dash intersect at point P. With point P as center and radius r3, we will draw an arc which will be tangent to the given arcs at points M and N respectively. Let's now erase the unwanted curve segment. And here we go. We have just drawn a tangent arc to given arcs. Another frequent requirement in engineering drawing is to gradually convert a curve into a single line. For example, do you remember this object? For this type of construction, we need to draw an arc tangent to a given arc and the given straight line. So without wasting much time, let's just do it. This straight line AB and arc DC of radius R1 need to be connected with another arc of radius R2. For that, draw a line A dash B dash parallel to the given line AB at a distance of R2. Now with center of arc DC, draw an arc D dash C dash of radius equal to R1 plus R2. This arc D dash C dash intersects the line A dash B dash at a point P. With P as center and radius of R2, draw the final arc. This arc makes the line AB at point M and arc DC at point N. MN is the required tangent arc. Pretty easy, isn't it? Let's now move further to ogee-shaped arc tangent between two parallel lines. But first, what is an ogee curve? Ogee curve is also known as reverse curve and is a combination of two arcs that are reverse of each other. Now AB and CD are the two given parallel lines. Join points B and C and bisect the line BC to obtain its center point T. Further bisect line segments BT and CT. From point B, draw a perpendicular line to cut the bisector line PQ at E. And from point C, draw a perpendicular line to cut the bisector line RS at F. With points E and F as the center points and radii equal to BB and FC, draw arcs BT and CT. The arc BTC is the required ogee curve. So this is how the tangents are used in engineering drawing. Interesting, isn't it?
So as you have seen that with using these kind of animations and using these kind of active learning processes, our understanding can be better. I would like to thank GTU for taking the initiative for the Cognifront software of the active learning. In the next portion, we will see how we can use the scale on the different bases. What are the different kind of scales? We'll see all these things in our next part of the lecture. For this lecture, that's all. This is Arpan Pandit from the Atmiya College signing off. Thank you very much.